Hey guys, so today we're gonna talk about something different. We've been talking about Altium and some of the cool things about Altium, and there's many things that we haven't even talked about, and definitely we're gonna talk about it. And the reason I didn't talk about it because I don't really know about it that much, but I'm gonna go about it very soon. I don't really get enough time to do it. But today we're going to talk about is Keysight ADS and how you can export your your Altium files into the Keysight ADS for some kind of analysis. So I have like a kind of small board here, and I'm very interested about this part. So that's the reason I want to do all kind of simulation. I want to know what is the S parameter values from here to here. I want to know here to here as well, because these two are my favorite focus to do the analysis. And the reason is because of this crazy bias that's around there. Like you can see, this pads bias stuff are very annoying in terms of like any kind of signal and trigger issues. So I want to kind of analyze it. I want to see the values. I want to see every nitty-gritty part of it. And ADS is a great tool. And to be honest, there's many others available, like so many good tools available, and you can definitely take use of it, like ANSYS, HFSS, SI Wave. There's many more, but I love ADS. I just like it, and the reason I like it is because I have 2 years of at least some free subscription because of my university, right? But once I get out of my university, I probably have to cry a lot, unless I get into a job who basically has a Keysight ADS or Altium, things like that, whatsoever. Those are just on my thought. So as I mentioned this, I'm very interested about this part, and the reason I'm very interested about this part is because if you know some of the basics, if I send a signal from here, and if the signal is coming here, for example, and think about the signal is like around 50 megahertz. By the way, I'm just using my mouse to write this thing, so definitely doesn't really look very nice in terms of my handwriting. So if my signal is coming here, it's gonna create problem this side and this side. It's because it's kind of technically creating a stub, right? And not only that, if my signal is coming here, and if these are floating, and definitely it's gonna give some kind of reflections, and the signal can bounce back. So it's definitely a problem. So there's many solutions you can use. Like you can just use a register here and then terminate it, or not terminate, like come to the ground. You can use there a register and come to the ground. And there's many kind of stuff you can do, and we're not going to talk about it. But the reason you have to do simulation is in the idea just to have a good feelings about it. And by the way, simulation doesn't tell you everything. It just gives you a good estimate. And as a Professor Eric Bruggeting said, that rule number 9: don't simulate anything unless you really have any kind of expectation or any kind of estimated values. But we're gonna just see how I can import this crazy ODB file, and how can I then simulate it and set up in the ADS. And I'm gonna use the EM simulation, and after that I guess I'm just gonna go to the RF Pro and talk about the most of it. So let's start the video. Let's get back to our topic. So let's just go to File and go to Fabrication Output. And once you go to the Fabrication Output, you can just click on ODB++ files. So I kind of got rid of all of the layer that I'm not really interested in. I only kept this four of them. These are my kind of interested layer, like ground and power and bottom layers, top layer. These are my interested layers. So I just kept them, and I kind of made some changes based on what I really want. Nothing too crazy. And then I just clicked OK, and once I clicked OK, it created this file for me. And once it created this file, this is basically the file you give it to your manufacturer or whatever it is. But you can also give it to ADS, and ADS can do a lot of cool things for you, which is wonderful, isn't it? So now if you want to export it to any kind of file in your folder, so that you can just upload it to the ADS, and ADS know what you're trying to do. So all you have to do from this file is basically going to the file, click on export ODB++, and then you're gonna select your folder here. So I have like this folder, which is saved in under the ADS tutorial, and you're gonna click it, whatever, and then you're just gonna click OK. And once you click OK, it's gonna be saved. So if you want to see the folder, for example, well, let's take my folder outside, because there might be some crazy folder. that you know what I mean, some crazy folder probably floating around, and probably people will be like, oh my gosh, you have all of the crazy stuff. Well, not those crazy stuff, by the way, I mean good stuff, but there's some kind of confidentiality I have, so I don't want to show those folder as well. So basically let's just I'm just basically using my other screen. Here you go. Okay, here you go. So it's on there. Now if I click here, you can definitely see all of the files that's important for me to simulate, right? I do have all the fonts, input, job, metrics, mix, step, symbols, user. You can just go inside of them and then see what is it. I also have an import file, and sometimes ADS creates a GIF file. I don't really see the GIF here right now, but we don't really care because we're not gonna do the simulation using tar or GIF format. So okay, so you have your folder, and that's great, that's wonderful. Now we're gonna go to Keysight ADS, and I was kind of doing some kind of simulation here, but I'm gonna do it again. Okay, so this is your basically, you click on the ADS, and this is basically your ADS window. I was kind of doing some kind of simulation. I can just delete it for now, but my main part of the whole video is just to show you how you can do it. So if you want to import this file, import this ODB++ into your Keysight ADS, you can just go to your file and you can click on import and design, and let's just talk about it. Okay, let's just talk about this part. There is like 4 things you kind of have to be worrying about. The Gerber file is basically if you have a Gerber file, and then you can do it. But the problem with the Gerber file is if you want to import a Gerber file, they don't really import you any kind of a stack manager or any kind of subtract. So you have to like kind of create a subtract or a layer manager manually if you choose to import it using a Gerber. But I'm using ODB++, so I don't have to worry about creating a subtract or any kind of like that because I already created one on my Altium, so I'm pretty much good to go. And as you can see, and there's like a 4 option. The legacies are basically for the older side, and I don't really want to use the legacy for now, but you can also use it for simulating it, and definitely they have some kind of their own advantages. Like one of the advantages of the legacy is you have the rights to select what kind of layer you want to import, what kind of file, what kind of components you want to use, and I can show you that. For example, if I just choose this legacy of directory format, and if you have like a GIF or tar, you can just click on ODB++ file format legacy. But I'm gonna just click on this one for now, and don't use the legacy for now. But I'm just trying to show you like what I mean. Okay, so I can just go to my Altium here, go to here, and this is the thing I believe I created. The job, select folder. Here you go. So once I have it, you can click on options, I mean the option from the file type, and you can definitely see in the layer as all of the things kind of uploaded. So you can just basically choose whatever you need, and you can also have some kind of NAS if you want to, but I don't really want to use the legacy, so I'm just gonna change back to my file format as directory format, not legacy. Okay, and now I have to again go browse and find the folder, which is not a really big deal in a way, I guess. You can just click on the Altium and here USB and whatever. There you go. This is basically the stuff I have. I can just click on the job, and that's probably gonna do my work as well. There's to be honest nothing to change. Most of the things are already kind of taken care of, unless you do have some kind of preferences. But I just kind of leave them as it is, and make sure you have your cell names and library names which are not duplicate of it. I'm just gonna say 22 just to give them a unique name, because I feel like I've used the job again, like any kind of file names that has the job before. So I'm just gonna click OK, and once I do it, look, it just took a very quick time to import the whole crap. So what I'm gonna do is clicking on the job 22, which I just recently created, clicking on the layout, and you can see that whole board has been imported, right? That's kind of awesome, isn't it? And you can also see some kind of other layer stuff. And the first thing I always do is clicking on the subtract here. As you can see, there's a subtract, and then if I just take the subtract here, then you can just like check what kind of thing you have. I definitely have a drill via here, which is going from my first layer to the down bottom layer. I do have one from first to second layer. I have a one first layer to the third layer, and this is my traces kind of showing up. And this is basically my internal ground, and in my power here, you have my bottom layer down there. That's all kind of things I need. And then I can also go and check that my FR4, the thickness of it, and FR4 basically your 4.6 as the dielectric. They calculate all the kind of stuff by manually. But if you really want to just add some kind of materials, and just to make sure, you can just click on basically this one from the materials, and then you can just play around if you want to. Like, you can go to the conductor, you can add some conductor if you want, and just you have to do is basically changing stuff. But I don't really care right now. I don't really want any kind of crazy things going on, so I just want to get rid of it. Oh my gosh, okay, where is it? Remove the conductor. Here you go. Then you can go to the dielectric. You can change the dielectric if you want to, and you can also define some kind of frequency stuff if you want. But I don't think I'd really play around with that much, because all the time if you're using ODB++, you don't really have to care about that part that much, because it's already being added from your Altium. But if you choose to do some manual kind of adjustment, you can definitely do it from here. All you have to do is clicking on this thing, and you can find a lot of subtract from the Keysight ADS library, so definitely take use of it. But whatsoever, we don't really care about it. Everything looks very perfect and great for me, so I'm just gonna go ahead and go to this EM setup. But we are not done yet, by the way. We have to do a lot of different things right now. So think about it this way: if you take a VNA, for example, right, and if you want to measure S21 parameter, what are you gonna do? You're gonna put the device, and you're gonna assign some kind of ports that, okay, I want port 1 to send the signal, and I want to see the signal is coming out on port 3 or port 4 or port 10, whatever it is. So we're basically doing the same thing here. We're gonna kind of define where is the porter, where is the port. Okay, we're gonna define those, and by defining them, we're gonna just making sure that it knows where to use the port and it knows where to go. So one of the easiest mistake I used to make is basically, so if you see, this is your kind of like traces. The traces are kind of not really balanced well. It's because of me. I made a mistake. I should have a straight line like that, but well, whatever. It's just a tutorial video. And I do have some traces, as you can see here, and I do have a conductor down there. They are basically, well, everything looks really well. So what you're gonna do, you're gonna click on the port editor, and if you click on the port editor, but before you click on the port editor, you have to make sure that you are on the top layer, but which I'm not in the top layer right now. I'm in the drawing layer, so I have to go to the top layer, and the top layer would be, you can basically find it from here, or you can also just easily find it from here as well. You can just click on here to find your top layer. So you must have to be on your top layer to assign your ports. So now I'm just gonna click on this, and I'm gonna click on the port. Port here. So I'm gonna click on the port, insert pin, and I don't really care about this stuff. I don't want to do any auto angle snap, auto layer snap, differential port, anything like that. I'm just fine as it is, and type in and out. I think that's fine as well. But now, one of the mistakes I used to make is clicking the port here, like assigning to very beginning of my SMA, which is a mistake, because if you click on the 3D view, you'll definitely see a mistake. So that's the reason I'm kind of making a video recently, not a video, kind of like I'm writing an article, and the article is basically here. Like if I show the article, so what basically happened, you could read my article if you want anytime. I'm just kind of still in the process of writing it. So what happened was I assigned the port, okay, I assigned the port here by mistake, like here by mistake, and when I assigned the port in the wrong directions, like here, okay, there's a great picture. I assigned the first port here, and because of that, my things is not working. So I changed this here from there, and then everything is kind of working. So we're gonna like kind of see that what's gonna happen here. So let's just go and start assigning our port. This is my first port here. Second port would be here. I'm kind of trying to avoid placing here because sometimes I kind of have bad feelings about it. But I think maybe it's not something to worry about. Maybe I can use this one here and use the other one here. Maybe I'm just being too paranoid about it. And then you basically assign the port based on where you want to see your signals, or what kind of part you're interested in. So definitely this is the part I'm very interested. So once I assign my port, I have total 8 ports, which are great. But I also have to reference them to the ground, right? I mean, if you have a positive pin, you need to have a negative pin. And how you can do it? And there is many ways to do it. The hard way to do is like going to your ground layer, for example. Like if I go to my second ground layer, and if I again click on the port, and if I just like shift them to the right, I can just click. I can just create some kind of reference like this, right? And they are really pain in the neck, and I don't want to do this because I have to like do it for 8 of them again. But ADS is very, very nice. They're gonna help you to assign your ground reference very easily. So I just define all of my positive one. Now I'm gonna just assign all of my negative ones. So to do that, if you can go to port editor, and then if I just expand it a little bit, you can see now it's saying implicit. Basically means is you'll try to find whatever the ADS will see as the best, or something like that. Implicit, whatever. I don't remember exactly what does it mean, but that's what I was reading when I was reading an article. But we're not gonna do it. We're gonna say go to, well, let's expand this just to make sure. We're gonna say go to your ground layer. So I'm gonna say ground layer, which is basically my second layer. So once I do it, I'm just gonna click copy, and I'm gonna just hold my mouse and just till it finish, and then I'm gonna just click on pass, and now all of them are internal ground, right? So that means I have a reference. And if you want to be sure about it, like, is it really working, you can just click on this visualization. Well, the reason it's not getting created because I don't have this EM setup yet. But I guess I'm done with this port setup, and I'm kind of interested about this part only. There's definitely a lot of things that you might be interested, which I'm also going to talk about very soon. But now is the part came to do the EM setup. But before I even do it, if you don't really like a lot of boards, like these components, you feel like this is going to take up your whole PC, and the way the simulation work, it depends on how good you use your laptop. Like my laptop is not the best. It's like Core i7 Intel. I guess it was like an Evo 1350 or something like that. So basically not the best. But if you have a very great PC, I mean, this shouldn't be a problem. But for me, just to simulate this part, it takes me like around 20 minutes or sometimes 30 minutes. And based on the frequency range, I'm defining it based on the mesh sizes and a lot of things, which we're going to talk about right now. But if you really want to like chop them, if you don't want to include this part, basically what I did, like same exact as this board, I basically chopped it. So you can do it as well. All you have to do is first defining a polygon. Like you can define a polygon here, maybe like something like this, and then once you define the polygon, now you can just chop it. You can just chop the whole board. I don't remember exactly right now how to do it. I used to do it all the time, but now I don't remember because I just made the video all on a sudden. Okay, here, probably this one, I guess. Something around here. I just don't remember how to do this. Oh my gosh. Here we go. It worked. Sorry, it worked. It's probably that part was the one which made it work. Crop to selected. So yeah, so once you do it, you kind of got rid of some of the components, and it's definitely going to save you a lot of time of your simulation. And it didn't really impacted my ports, so you can see still my ports are there. They're kind of chilling around. So I guess we're done with this part, and now I can just go to my EM setup, and I can do some kind of EM setup round. So just create a simulation here. So in the EM setup, you have 3 options. You have momentum RF, which is the fastest way to do simulation, and you have momentum microwave, which is basically a 2.5D. So basically it's a little bit more complex. And momentum RF is basically a 2D. And FEM is a 3D. FEM is like a perfect solution for if you really want to simulate whole the process of your circuit board. Then definitely the FEM is way to go, right? But if you're not really worrying about your 2D, 2.5D, or 3D, you can just choose whatever you want. So for now, I think I choose a momentum microwave on this one, which I kind of simulated before. And then you can do some kind of changes. Here I think everything looks very much fine, and now if you go to the partitions, which basically tells you what's going to happen, like what kind of instances are going to happen or things like that. I guess there's nothing really special. And if you made some kind of error before, the EM setup will tell you what kind of error you have made, but good thing we didn't make any kind of errors. Then you have your substrate here, you can look into it. You have your ports, which we already have defined as a ground, as you can see. and you have a frequency plan, which is you can define. By the way, I will just go with 2 gigahertz, and all I need is this. From 0 gigahertz to 2 gigahertz will be my frequency sweep. And my output, it's kind of important because sometimes the output kind of depends on how you want to store it, how you want to store all of your EM setup results or stuff like that. So you can save all generated frequency if you want, but that's gonna take a lot of storage of your whole simulation file, and it probably will take a lot of time, I guess. And you can also say user specified frequency. I'll just click on user specified frequency for now, and you can also do some kind of thing if you want to, but I think we are all set for now. And now this is the option field, which is a very vast. Like, you have to really understand what the option is. All of them is very important. The reason is there are so many things, and it's really not possible for me to go over all of them. But I'm just gonna give you a very good overview. So what is physical mode? On this one, you can basically tell ADS that how to view your via, how to view your thick conductor. So if you use 3D distribution, it's definitely gonna take a lot of time. As you can see from this text, is saying DC resistance and skin effect is gonna count them. It's gonna count for your DC resistance and skin effect. And it's going to also count them for all self and mutual inductance and capacitance and any surface current. But if you change to like a wire, for example, it's just not going to do a lot of stuff, but it's going to definitely think of it as like a resistance, and like it's already telling you like a wire self inductance, mutual wire to wire, wire infinity ground inductance, meshless equivalent circuit. But the great thing about the wire is basically helps you to simulate your whole simulation very fast. But if you use 2D, it might take a little bit more time. But if you use lumped, it doesn't really bother at all. So I just always use wire because I don't really think I need a 3D distributed right now, or distribution kind of simulation. And you can define some of the thing like layer specific stuff, how you want to see it. I just use them as a wire. You can also change it if you want to, or if you're okay with that, that's also great. Not a specific. You can also change them based on your preferences, however you want to. I just use wire for my faster simulation. But if I buy a great laptop in the future, if I have like you guys who does a lot of gaming, so if I have a great laptop, I might use this 3D stuff. And then in the processor, you can define all of your kind of some of the little bit of, basically I think it was about like layout stuff, I guess. I don't really remember, but it's the preprocessor is basically how you can pre-process your simulation and things like that. I don't really care about it right now. And the mesh size, mesh is very important. It kind of defines you like how fast you want to run the simulation. So in the mesh, you can define the mesh size, your wavelengths. The smaller it is, the better the resolution, but the better the resolution, the longer it takes to simulate. So you can define your cell or wavelength size as well, and you can get rid of it if you really don't want mesh reduction. Then transmission line mesh, things like that, definitely something to care about. And you have this whole setup here as well, and you can reduce this as like a 10 if you really don't care about the bottom layer. You just click as a 10 cells per width or something they call. That's kind of up to you, basically. That's all up to you. And once you do this thing, you're pretty much all set to go. And resources are not really critical for me right now, and we can talk about it later. And that's your basically EM model. You can just click on EM, ensure that EM model exists when the simulation is launched, and the nodes or whatever it is. But before you even simulate, as I mentioned about that, how you want to visualize your ports, you can just click on that, and that's gonna help you to see how your ports are looking at. And once you click on that, there will be a job file manager will pop up, and it will basically try to generate trying to create that visualization, so that it will help you to see how your ports are looking like, how is your board are looking like. By the way, I feel like I'm talking a lot, and I'm getting a little tired because I just kept talking and didn't have any kind of food so far, so I'm definitely very hungry right now. And I guess once you kind of make sure of the visualization looks great, you can just click on the simulate, and once you click on the simulate, you'll be all set to go. By the way, my EM visualization is still under process, and as I said before, the speed time depends on your laptop, how good is your laptop. If you're a poor guy like me, definitely it's gonna take a lot of time. But let's give you let's just walk through like how the values should look like till we open this EM visualization and stuff. So once you're ready, once you feel like everything looks great, you can just click on the simulate stuff, and once you click on the simulate, it's gonna create this file automatically. And here you can check your all of the file as you need. Like it's already created some return loss of my first port and also the phase, which I really don't care about. These things are very interesting, how there's always a negative phase and how it's kind of working. I've read one of the book of the Professor Eric Bogering, and he kind of explaining about like how this phase is kind of negative, goes to the negative 90-degree shift, all the phase shift, negative 90 degree of phase shift, all this happens. This is kind of like a great article. If you have time, you can look into it. And I was looking to my return loss of S11 looks very great, to be honest, not too bad. I mean, this kind of go really bad as this goes to 2 gigahertz of frequency, but still is pretty good. And that's my insertion loss of port 1, 2 and port 8, 7. So what I basically mean is, I don't know why this is not really opening. What it's saying basically, open 3D current or field information required for visualization and use save current for to use a different frequency. Oh, okay. Well, then we can just do this one then. 3D overview. My bad. I was using the visualization by mistake. I should have been using this 3D EM preview. My bad. So you basically click on this 3D EM preview just to see how your ports are looking like. And then you can already see that your job managers kind of start running it. And we're going to talk about it very soon. But as we are kind of saying it's going to generate this. Well, this won't get generated. You have to kind of create it manually. So you can just click on this table and you can just place it here, and then you can just choose whatever pin you need. You can check your isolation. So if you want to check your isolation, you can just click on port 8.1. That's going to kind of give you a estimation of how isolated your device is, which just looks pretty good. Negative 100 dB is like no signals are kind of like passing through. And basically that means is your insertion loss from here to here, if it's very high, that's great because there is a great isolation. And S21 is basically from here to here, as 8.7 is basically from here to here. So this kind of results you were kind of seeing around, and definitely very great to look into some other as well if you have time. My laptop is very slow, to be honest, so it's still taking a lot of time to generate me this EM preview stuff. So let's just wait till it just kind of start. I might pause the video if I don't really have anything to speak. I'm kind of very tired today for some reason. I've been in my class, and after doing tons of classes and assignment and homeworks, quizzes, I don't really have energy. By the way, it just popped up talking about all of my frustration. So as you can see here, we have our port, and the port is there. As you can see here, is going down. And if you see this one is saying your color red is basically your top layer. And you can definitely also see your other layer as well. And here you go. So red is your top layer, and where is it? So red is your top layer, and wait, I'm just trying to make it more look nicer so that I can basically show you what I mean by it. Then you have your ground layer, which is a kind of brownish, and then you have your power layer, which is a greenish, as you can see here. It's kind of like very complicated to see how it is kind of working, but if you start kind of playing around with that, you'll probably understand what I'm basically meaning. So that's it. That's kind of like showing you that all the ports and how they're referencing to it. That's always make sure that it looks good before you start doing a simulation, and just try to see like how it's kind of referencing to it. I guess everything looks pretty good so far for me. And conductor all visible, I can also say none, and if I say none, then I can just go to the materials, and then I start clicking on this is my top layer, this is my ground layer, which is right beneath of it, and then I have my power layer down there, and I have my bottom layer. So that's it. I guess that's all for this video. I know it's very long right now. It's almost like 30 minutes, I guess. So many things to talk about it, and I feel like that's it for now, and I'll see you guys in the next video. Sorry for all of the conversation and all of the time that I probably taken from your life.